Hello and welcome to the GCSE Particle Model of Matter topic with Mrs Castanera. We're on lesson 10, Particle Motion in a Gas. Today's key words are Brownian motion, temperature and pressure. I'm going to highlight those. Then we have the exam specification telling us what we're going to be learning about today. And then we have our knowledge check. So pause the video whilst you complete the questions on the knowledge check, please. Okay, so let's go through those. Question 1. Identify the unit of specific latent heat. Well, that is joules per kilogram. Please make sure you're writing in a pen of a different colour and that you're marking and correcting as you go along. Question 2. Define specific latent heat. Well, it's the amount of energy required to change the state of 1 kilogram of the substance with no change in temperature. Question 3. What happens to temperature during a change of state? Well, it stays the same. Question 4. What state change is represented by the latent heat of fusion? And that's from solid to liquid. Question 5. Identify the unit of specific heat capacity. That's joules per kilogram per degree Celsius. Question 6. What are the 3 basic states of matter? That's solid, liquid and gas, not plasma, because these are the basic states. Question 7. What three factors is the energy rise with substance dependent on? So there's a few here. There's mass, specific heat capacity, and change in temperature. Those are the 3 things. So you get a mark for each. And question 8. In which state are atoms moving around the quickest? Well, that is gas. So give yourself a mark out of 10 for that, please, because there are 10 marks. So moving on, this lesson we're going to be looking at molecules of gas are in constant motion, so that's just a statement of fact that we're going to know to be true by the end of this lesson, and that changing the temperature of a gas will change its pressure. So we're going to look into these 2 things today. Okay, so we're going to move on to the next page. So, the states of matter. What is matter made up of? Study the following video to review the properties of the states of matter. So you should all have access to a digital copy of this, so click the link or type it in and you'll be able to watch the video. Whilst you're doing that, feel free to pause the video whilst you're watching it. Make notes on how particles move in solids, liquids and gases when they are heated. Okay, so pause the video whilst you watch that and make those notes. Okay, so during the video, hopefully you identified that the molecules of gas are in constant random motion, and that the hotter the gas is, the faster the molecules will move. Since the motion is random, not all the molecules will move with the same velocity, that means speed in a particular direction, and the same kinetic energy. So they all have different velocity and kinetic energy. I'm going to annotate what velocity is because I think it's important that we remember this definition. So velocity is speed in a given direction. Okay, so the temperature reflects the average kinetic energy of the molecules. So the average kinetic energy of the molecules is temperature. Okay, so checkpoint question. Describe the motion of molecules in a gas. Pause the video whilst you answer this question. Let's go through that. The molecules in a gas are in constant random motion, with each particle having a different velocity and different kinetic energy. The hotter the gas, the higher the average kinetic energy of the molecules. Okay, so there's a few key points here. Make sure you've got all these statements written out. Add anything you haven't got. Feel free to use your student notes page to get that written down if you don't have space on this page. We're going to move on to Brownian motion. Particles in both liquids and gases, which we call fluids collectively, so liquids and gases collectively are called fluids, move randomly. This is called Brownian motion. So Brownian motion is the random movement of particles. I'm going to write that in. Okay, so Brownian motion equals the random movement of particles. They do this because they are bombarded, that means repeatedly hit, by the other moving particles in the fluid. Larger particles can be moved by lighter, fast-moving particles. Brownian motion is named after the botanist Robert Brown, who first observed this phenomena in 1872. So he used a microscope to look at pollen grains which were moving randomly in water. And at that point in time, he couldn't explain why this actually happened. So the video, which is linked here, demonstrates this phenomenon, and it is an experiment you can do at home if you have access to pollen or seeds or something small like that. And that's shown in this video here. So you should be able to click on these links if you have a copy of this. Digital copies of this are available on your online learning, or ask your teacher for help or myself. So in 1905, physicist Albert Einstein, who I'm sure you've heard of, he explained that the pollen grains were being moved by individual water molecules. And this confirmed that atoms and molecules did exist and provided evidence for particle theory. So that's rather exciting. So this Brownian motion observed when we saw pollen grains moving randomly in water was evidence for particle theory. So we're going to move on to page 26, gas pressure. So since the particles in a gas are moving very fast and randomly, collisions are occurring frequently. These collisions may be between two particles or between a particle and the wall of a container. So two particles could bump into each other, or they could just hit the edges of the container. So the force acting on the container due to these collisions is at a right angle to the container. Okay, so what we're saying is it's pushing out. So the force is pushing out onto the container wall at a right angle. So we have our container here. Okay, and we find that the force, on average, is pushing at right angles, or 90 degrees. Okay, so that is 90 degrees. Okay, and that's the force from the particles on average. And that force is exerted on all the sides of the container. Okay, so you can see that from the diagram here. This force per unit area is known as gas pressure. So the pressure from the gas molecules can increase if there are more molecules colliding, or if the molecules are moving faster. So the gas molecule pressure increases. So pressure increases if there are more molecules colliding or if they are moving faster. So let's talk about the relationship between temperature and pressure now. So for a constant volume of gas, so the same amount of gas, if the temperature is increased, the pressure will increase. Okay, so we're talking about the same volume, that's the same cubic meters. So you could talk about a container of a fixed size, and we talk about a constant volume of gas. Okay, so if the temperature is increased, then the pressure will increase. So in fact, for a constant volume of gas, temperature is proportional to pressure. So proportional means that it relates to it. So if temperature goes up, pressure will go up. Temperature goes down, pressure will go down, and that'll be by the same amount. Okay, so if temperature doubles, pressure will double. So checkpoint question, what effect does increasing the temperature have on the pressure of a gas when held at constant volume? So to answer this question, pause the video whilst you do that. So let's review the checkpoint question. So what effect does increasing the temperature have on the pressure of a gas when held at constant volume? Well, if temperature increases, then pressure will increase. That's the first mark. The second mark was for saying that they are proportional to each other, or for using the phrase proportional in the description. So there are 2 marks here. Okay, so we're going to move on. So, particle motion. We have this simulation, the PhET simulator, for the particle states of matter. It doesn't always work, because I've found the link's not currently working, so it might work again by the time that you use this, but I haven't been able to use it at this link at the moment. They were talking about replacing it, but it hasn't yet been replaced, so it might work for you, it might not. So question A, think about what's happening to the motion of the particles and the pressure as the temperature is increased at constant volume. And B, have a look at what's happening to the pressure as the volume is changed at a constant temperature. So watch the video, which is hopefully going to be available at this webpage. It may not be, unfortunately, but there's nothing I can do about that, I'm afraid. So then use your knowledge from this, if you can, to pick the words from the list to describe the motion of particles in a gas. So this is the list of words. You'll need to pick which ones describe the motion of particles in a gas, and for bonus points, put those words into a sentence, or 2 sentences if necessary, about the motion of the particles in the gas. Okay, then there are more questions on page 27, okay, and it carries on all the way to part D of question 7. So pause the video whilst you answer the questions, please, and then we'll go through them together. Okay, so the words you need to select were random, rapid, collisions, spaced, and vibrations. And I've put them into an example sentence, which if you haven't got one, I'd like you to write out. So the particles vibrate rapidly or rapidly vibrate and move in random directions spaced well apart with collisions between the particles. That's an example sentence. You may have a very different one as long as it's using the same words. Okay, and you get a mark for getting all 5 correct words and a mark for putting it into a sentence. So that's out of 2. So question 2, if temperature increases, what happens to the speed of the particles? Well, speed will also increase. Question 3, draw some gas particles in the box on the right. So I've drawn some example gas particles. To get the mark, you need to have them a similar size. They need to be well spaced out, so not all close together, and definitely not touching. Okay, so these are 3 things. So I'll give you a mark for each of these. If they're similar sized particles, they're well spaced, and they are not touching. So up to 3 marks for this question. Question 4. If you shrank the box but kept the same particles and the same temperature, what would happen to the pressure? Would it increase, decrease, or stay the same? Well, it would increase, so you get the mark for that one. If the box stayed the same size but you made the particles move faster, what would happen to the pressure? Well, pressure would increase. Question 6. If you kept the same box and the same temperature but doubled the number of particles, what would happen to the pressure? Well, in this case, it would increase because there are more collisions, because there are twice as many particles. Question 7 is very hard, but don't worry about that. You're going to do the... Doesn't matter if you've got it wrong, as long as you've tried. So if the pressure of a gas is halved, the box stays the same size, what happens to the temperature? Well, temperature will halve. Okay, and the reason for that is because you've got the same size of box, but the pressure goes down. That essentially means the gas is less squished and has less energy. Okay, so it's going to have a lower temperature. B. If the temperature is doubled and the box is half the size, what's going to happen to the pressure? Well, it's going to quadruple. And the reason for that is when you double the temperature, the particles are going to have double the pressure. And then when you cut that box size in half, okay, you're going to take away space, and so those particles are going to be more squashed together. So you're going to double it again. So doubling and twice, it makes quadruple. Then lastly, if the temperature doubles and the pressure doubles too, what must happen to the box size? When you double temperature, that would double the pressure, so automatically. So you wouldn't need to change the size of the box at all. So you would have to keep it the same. So D, if the pressure stays the same and the box is made twice the size, what is the new temperature? So when you make the box twice the size, your pressure is going to half. Okay, but pressure has stayed the same, and that tells us that you would have to double something to keep the pressure the same whilst maintaining the box at twice the size. So the new temperature would have to be double that of the old temperature to maintain the same pressure in a much bigger box. So it's going to be double. So give yourself a mark out of 13 for that set of questions. If you have got 7 or more, then that's exceptionally well done, okay, because question 7 was particularly hard, okay. If you've got more than 7, then you've done very, very well, so well done. Moving on. So moving on to the knowledge check on page 28. So there are 11 questions. I want you to pause the video whilst you answer the questions, please. Let's go through those questions. So name the 3 states of matter, using a pen of a different colour to mark this. The answer to question 1 is solid, liquid and gas. You can have plasma as well, but you would need to have written all 4 for that. So I need solid, liquid and gas as a minimum for the mark. Name the unit of latent heat, that is joules per kilogram. Question 3. As gas heats up, what happens to the speed of the particles? Well, the speed increases. What does temperature reflect about the molecules? It tells us the average kinetic energy. Question 5. If temperature increases in a gas, what is the effect on pressure? Well, pressure will also increase. Question 6. If the pressure of a gas increases, what happens to the motion of the particles? Well, they're going to speed up. Question 7. List the states of matter in order of decreasing speed of the particles. That's from gas to liquid to solid. Gas being the fastest, highest speed, and solid being the slowest or lowest speed. Question 8. In a sealed container, what will happen if the temperature increases unchecked? Well, pressure will also increase unchecked. So if you've written pressure will increase, then that's good. So it's going to increase unchecked until the container is no longer strong enough to contain the extremely high pressures, and it will explode. It may not fully explode, it may just break, burst open at the seams, a bit like if you overinflate an air mattress or something else with seams at the side. Sometimes the seams can just split and the air will squeeze out that way. Or it could be more like a balloon. You keep blowing it up until it's no longer strong enough and it doesn't have a seam to break along, and then it explodes. So there's multiple options for how it will be destroyed, but the container will be destroyed. So there's 2 marks for that one. Question 9. Why does water boil at 71 degrees Celsius on top of Mount Everest? Well, this one's a tricky one, but the air pressure on top of Mount Everest is so low that water particles can vaporise at lower temperatures. So if you've written that the air pressure is lower, then you can have a mark. And if you've said that means that water particles can vaporise or boil at a lower temperature, you can also have a mark. So there's 2 marks there. And that's because the energy required to achieve vaporization is reduced in lower air pressure. Okay, so there's 3 ways of getting a mark there. And you can have any one of those 3, and we'll make it out of 2, in fact. So any 2 of those statements out of the 3 will get you a mark up to a maximum of 2. Question 10. List 3 things that affect the rate of diffusion. So temperature, or kinetic energy, concentration gradient, or surface area. Question 11. Define the term osmosis. So osmosis, this is definition, the movement of water molecules through a selectively permeable membrane down the concentration gradient. So sometimes you might have said movement of water molecules down the concentration gradient, or from an area of high to an area of low concentration. That's worth 1 mark. If you said through a selectively permeable membrane, then you can have a 2nd mark, because that's a very good answer. Okay, so give yourself a mark, please, out of 14. Okay, so if you have got 7 or more, you've done well. If you've got 10 or more, that's extremely well done, because those last 4 questions were incredibly tricky. So at the end of our lesson, before we move on, we have got the keywords, which are here, which you should know, but you do need to learn. And finally, we have got the lesson summary video, which you have the link to here. So you can either follow this link by clicking on your digital copy of the document, or you can type it in. I highly recommend getting a digital copy and clicking on it. If you have any questions, email your teacher. Thank you very much. That is the end of our lesson.